Well, hello everyone, and I'd like to add my welcome back to Oxford. I hope some of you from the 2015 meeting recognise this scene. Can we have the lights down, by the way? Because some people might like to sleep. Thank you. So the 2015 meeting, which was one of Dr. Sahale's great triumphs of organisation, a very ambitious plan indeed. So today I'm going to speak about snakebite species identification, and I'm calling it a threat. It's threatened by inexpert practice. A cautionary tale means that there's a warning embedded in this talk. And I really have to take some responsibility for the drive which has encouraged people to identify particular snakes responsible for bites, rather than just saying a snake bite, a specific bite. So there have been many retrospective series of cases and even clinical trials or case reports where no mention is made at all of which species of snake was responsible. But they're often shrouded in general terms like poisonous or non-poisonous, or vipers and things like that, which is clearly inadequate. And to make matters worse, some very experienced snakebite clinicians don't think it's important to identify the species. They say, well, we have polyvalent antivenoms in our country. They'll cover the bites of all our snakes. So what are the problems with lack of species identification? Two quick examples. This large series from Tamil Nadu, 533 patients, a retrospective audit to look at various aspects of snakebite management. And there was no identification of the snakes responsible. All the authors could tell us was that in this region, there were Russell's vipers, common cobras, and common kraits. And as you might expect, the results were uninterpretable because no one knew which of the patients was bitten by which species. And here's an example of a small clinical trial, also from India, from Kerala, where 100 patients were randomized to two groups. Well, randomization is good, of course, to two doses of antivenom, but irrespective of severity or whether they were bitten by any of these major groups of genera of venomous snakes. And the authors had to conclude that most outcome, although they showed perhaps a trend, the differences were not statistically significant. So yet again, uninterpretable results. So why is it so important to identify which species of snake has bitten your patient? In an audience dominated by laboratory venom toxinologists, I don't have to explain to you that there's overwhelming evidence now that the composition of venoms is grossly different between different species and even between individuals within a species. The species diagnosis helps to optimize clinical management as well, because you're then in a better position to choose the right antivenom, and even if it's a polyspecific antivenom, to choose an appropriate initial dose, depending on what species is involved. Also, the species diagnosis is absolutely essential, I would argue, for research on clinical features. This research defines clinical phenotypes or syndromes as a basis for syndromic diagnosis and management algorithms, which are very important in most of the hospitals in snakebite endemic countries that don't have access to more specific methods of identification. But if they can identify which clinical syndromes involved, they can at least make a pretty good guess which species was involved. Well, nowadays, thanks to this pressure to define species responsible, for which I admit I was partly responsible, journals and reviewers demand this identification in clinical case reports and other studies. The trouble is, things have gone a bit wrong, and that's the point of my talk, is to illustrate in a way, this vicious circle. One advantage in discovering these problems is that the images, the photographs on which the species diagnosis was based are often published in the papers, and this allows you to scrutinize the evidence. Which then are the reliable research methods for species identification? I think we'd have to admit the gold standard is examination of the dead or living snake itself, the one responsible, by an expert. And expert, I shall be taxing that definition of expert in the next few minutes. Either of the snake itself or of increasingly iPhone images of the snake involved. Or you can use immunodetection, specific venom antigens in wound, swab, aspirate, blister fluids, serum, urine, and other body fluids. PCR detection of snake's DNA in a wound, it sounds very exciting, but the method has not yet been fully published. Then there's inference of, as I said before, inference of the species diagnosis based on what you observe in the patient, the clinical syndrome. This, I would emphasize, is strictly for medical management. It's not reliable enough for as a research method. And I was rather surprised to see this paper published in Toxicon recently, in which it stated that snake species was authenticated by a validated syndromic approach based on a venomous snake identification algorithm. Certainly for the clinician, that's very helpful, but not if you're studying trends based on specific species responsible. So let's look first at this expert examination of the snake or an iPhone image. Sounds very reliable. So what could possibly go wrong? And the most fundamental thing is that the snake brought was not responsible for the bite. And I learned this lesson very early on when I was working in Nigeria in the 1970s. A patient with all the typical features of envenoming by carpet viper brought a very mangled specimen of this particular very innocent looking snake, completely innocuous sandburr. And that was clearly the relatives or patient felt that the hospital would expect a snake to sort of confirm the suspicion. So they brought this innocent chap along. Now, another example, this paper was published from Yaoundé in Cameroon of severe Viperidae envenomation. And the authors state that a case of a farmer who sustained a snake bite by an Echis oscillatus viper during an agricultural activity. Well, that's absolutely to be expected in this area of Cameroon, perfectly reasonable expectation. But the authors then said the victim killed and beheaded the snake and produced this picture, which is clearly not a carpet viper, it's a forest cobra. And when the authors were approached about this, they later admitted that they'd borrowed the image from another publication. So this, you're going to see the ill effects of my campaign to get people to confirm the diagnosis. Any old picture will do to provide the evidence. Another problem is that the iPhone images may not have the resolution to show diagnostic features. So this particular patient was bitten in Pahang in Malaysia, and the diagnosis made by examination of this particular image was that the cause was this particular species, Trimeresurus sabahi fucatus. But there's another green snake in the same area, that Trimeresurus nebularis, which is really very similar. And it's quite impossible to distinguish the two just from this picture. I'm not saying that photo identification is not reliable. I hope you've all come across the iNaturalist network. And this is a superb system whereby people photograph snakes, often by iPhone, and put them up in front of an international audience online. And these pictures are very critically scrutinized by experts, people like our colleague Wolfgang Wüster, for example. And the ones that are approved and authenticated, you can guarantee have gone through this extremely strict filter of expert examination. So photo identification can be very reliable, provided the people making the assessment really are experts. Now, this is another suspect term that you may come across in publications increasingly, that the identification is made by a local expert herpetologist. That sounds absolutely right, doesn't it? Local, so they know the local snakes. Expert, lots of experience. Herpetologist, a specialist zoologist in reptiles, particularly snakes. But here's an extraordinary example. This paper appeared in proof stage online in an emergency medicine journal. And the statement was that based on photographs obtained of the captured snake, a local expert, you see, identified the snake as this very exciting Rhabdophis keelback, Rhabdophis subminiatus, which is native to this region. Well, I'm sure many of you will be questioning that diagnosis just looking at those pictures which were published with the paper. That was the giveaway. In fact, this snake is nothing like the species of redneck keelback that is in the peninsula, the Malay Peninsula, which is Rhabdophis siamensis. And it clearly is an example of this mangrove pit viper, Trimeresurus purpureo maculatus. And it's clearly not native to this region either, because that shows the distribution of the two nearest species of Rhabdophis, and they're nowhere near Singapore, which is where this bite occurred. So we remonstrated with the authors. My initial remonstration was rejected on the grounds that their local expert was absolutely top quality. But I brought in some heavies from the region, and they eventually were persuaded. And the paper was published with a very subtle alteration. Wherever they mentioned Rhabdophis subminiatus in the original paper, it was now Trimeresurus purpureo maculatus. So magic. And but incidentally, if that paper had been published, the results suggested that the antivenom used for green pit vipers, Trimeresurus, was effective against envenoming by this colubrid snake of the Rhabdophis genus, which would have been extraordinarily misleading. The trouble is that not all herpetologists are expert, not all toxinologists are expert herpetologists. And here are just two examples. I discovered this picture, this image, in a famous American textbook of critical care toxicology. It's our old friend again, but now called a temple pit viper, Tropidolemus wagleri. In fact, it's our old friend, the mangrove pit viper, as I've just been discussing. And when I remonstrated with this author, he's told me that a cursory glance shows both are quite similar, possibly an excuse for misidentification of my image. I leave it to the members of this audience to decide whether, are they really that similar, even to non-herpetologists? Another example, and I'm sorry to emphasize Australians in this, this is not racist in any way, Glenn and co. You know, I love all Australians. Here's another one. This antivenom update had a picture of what was labeled as a tiger snake. And there's rather a famous name attached to this particular picture. However, this is not a tiger snake. It's a broad-headed snake, a different genus, Hoplocephalus. That's the real tiger snake. So not all striped snakes are tiger snakes, even in Australia. When I remonstrated with these authors, you see, I do an awful lot of remonstration. Remonstration, by the way, means taking people to task or asking them, questioning their decision. These particular Australian experts said, we all spend as little time as possible around snakes. What an admission for people who study snake venoms, but clearly quite acceptable in Australia. So another method of diagnosis is immunodetection. And as we all know, the only commercially available system in the world, to the great credit of the Commonwealth Serum Laboratories in Australia, is the famous SVDK. Unfortunately, I hear that it may be withdrawn fairly soon, which I think would be a great pity. The trouble is the results of the VDK are easy to misinterpret. A positive test, for example, detecting specific venom antigens in the superficial wound swab is not alone an indication for antivenom treatment, because the venom may not have been injected. This doesn't mean that the patient was necessarily envenomed. And a negative test doesn't exclude envenoming, so you can't just sort of go home and leave the patient because it's negative. There are also increasingly described cross-reactions, not only between the genera listed here, but also with other genera present in Australian venomous snakes. Finally, proven unreliable methods include victims and onlookers' descriptions, however well-intentioned, because they're not trained as zoologists or as herpetologists. They may be misled by features of the snake which are not important. Also, recognition of photographs in the emergency room or preserved specimens, that's unreliable. And even the use of accepted local snake names for particular species. So here's just one example. This patient was bitten in Sylhet in northeastern Bangladesh. And the authors say that the species involved was a Trimeresurus gramineus, a venomous snake commonly encountered in South Asia, particularly in Bangladesh. Well, the snake species for this report, which described clinical features of this particular patient, was identified based on the patient's description, as the snake was not available for direct examination. Now, this shows the enormous advantage of iNaturalist. This is the distribution of this particular species as mapped by iNaturalist, showing that the most easterly records of this snake are a long way from Sylhet in Bangladesh. So it's very unlikely indeed that this snake was this particular species. And another point I want to make from this iNaturalist map, this picture is from the fantastic standard textbook by Ron Whitaker and Ashok Kaptin, published in 2004. Just look how the distribution of this species has been extended in that distance of time. So, and this is a plea that herpetology doesn't stand still. You have to keep up with the literature in herpetology as well as with toxinology. So, ladies and gentlemen, I'd like to conclude this. I've argued that snakebite species identification is threatened by inexpert practice. And this is a sort of warning, cautionary tale. I hope that I've persuaded you, if you weren't persuaded before, that identification of the species responsible is important, not only as a research method, but also for the management, the optimal clinical management of individual patients. And also, I think it's certainly a justifiable demand for publication. However, misleading or even dangerous misidentifications can arise from inexpert diagnosis, misinterpretation of immunodiagnostic methods, and reliance on snakebite victims' descriptions. So the message today is be cautious, be critical of what you read in the journals. Thank you very much.